The Kermit is Israel's main lake, and for a long time, it's been supplying drinking water to much of the country. People got used to thinking of it as an endless source until its levels started to drop. At some point, Israel decided to do something no other country had ever done: make the sea climb uphill. Hills and tricky terrain didn't stop them. The inventive nation made the water flow upward with the help of powerful pumping stations. Nearly $300 million was spent, and a massive amount of land was dug up. All of this just to bring salty water from the Mediterranean Sea into the lake that gives Israel its drinking water. It sounds insane, but if you live in a country where every drop of water is worth its weight in gold, that kind of insanity becomes engineering. The main lake of Israel. If you look at the map of Israel, Lake Kinneret looks like a big shining mirror in the northern part of the country. But this mirror reflects not the sky. It reflects the fate of an entire nation. It's also called the Sea of Galilee. Though the name is a bit misleading, the water is fresh and it's actually quite small, only about 12 miles long and 7 miles wide. Yes, its importance is far greater than it seems. Without Kermit, Israel wouldn't exist. Once Kermit was a quiet place of fishermen. They caught tilapia, watered their fields with nearby streams, and lived like that for centuries. But in the 20th century, everything changed. Israel turned Kinneret into the heart of its water system and made the water flow where it had never gone before, deep into the desert. In the 1950s and 60s, the country was growing at a crazy pace. The population kept increasing and cities were stretching south into areas where there simply was no fresh water. That's when a plan appeared that would change Israel forever: to build a national water carrier and make life flow through pipes. Literally, it was like carving a man-made river out of stone. The Israelis dug millions of cubic feet of rock, cut through cliffs, and poured tons of concrete. The project cost 5% of the country's GDP, an insane number for those days. But there was no other choice. Eventually, pumping stations, tunnels, pipelines, and reservoirs stretched out from Kinneret's northern shore. The system extended more than ATM, running down the slopes of Galilee through valleys and hills until the water reached the country's central regions, and even farther into the dry Negev. Where there had once been only sand, the impossible began to happen. Fields and orchards turned green. When the water carrier was launched in 1964, it was a national milestone. Israel felt for the first time that it could control nature, that it had its own almost magical vein feeding the land. Kinneret became more than just a lake. It became the artery of the nation. Every year, about 105 billion gallons of water came from it. That's almost half of Israel's total consumption at that time. The water from Kinneret flowed through taps and homes, irrigated fields, and reached the southernmost kibbutzim. Thanks to the lake, Israel didn't just survive, it flourished. And yet, like any heart, it has its limits. The more the country took, the faster the lake was fading. There came a moment when Kineret began to truly suffer. Lifeline is gone. In the 1960s through the 1980s, the water level in the Kinneret stayed around minus 686 to 689 feet below sea level. That was the norm everyone was fine with. Israelis pumped water for their needs without worry, and the lake naturally refilled to the proper level. But by the end of the century, droughts became more frequent and severe, and the gauge needle kept dropping lower and lower. The Kinneret was shrinking. In winter, when they usually expected a rise, there was barely any. And in summer, during the active pumping season, the level would fall by dozens of inches. In 2001, it reached the lower red line, 699 feet beyond that mark. The very processes everyone feared most began. Salt started rising from the bottom. The water turned bitter. The ecosystem began to collapse. Scientists warned another 3T down in the lake that had been watering the country would turn into a salty puddle, almost a dead sea. Here for in of water equals nearly 528 million gallons. So when the level dropped even by 3 feet, Israel lost billions of gallons, enough to supply entire cities. But even then, the country couldn't give up its lifeline. There were simply no other sources. Israel kept pumping even as it watched the lake weaken. Yes, At some point, Israelis began taking less water from the Kinneret, but the lake still shrank badly during droughts. The problem wasn't only internal consumption. The main source, the Jordan River, was bringing less and less water. Its headwaters in the Golden Heights were drying up earlier each year, and the rainy season was getting shorter. In the north, in Lebanon and Syria, dams and pumping stations were built, cutting off part of the flow. The Kinneret was missing out on hundreds of millions of gallons. By 2008, the worst fear came true. The level dropped below the black line minus 705 feet. That was a record low when pumping stations could barely operate. The country's main artery was drying out. Boats lay stranded on the bottom. Tree roots sticking out of the silt marked the new shoreline. Newspapers ran headlines like, "Kinneret on the brink and the lake needs help." But where could they get water if the Kinneret itself had been the salvation? All around is only desert and rock and one sea looming over the country from the west. The salty Mediterranean, second wind. So the Mediterranean Sea. It seems like an endless source of water. You'd think there's the solution. Just fill the lake with seawater, and the problem's gone. But the lake plays by its own rules. Seawater's way too salty to be mixed with a lake that supplies drinking water to a whole country. It's like pouring brine into a bowl of spring water. It's liquid. Yes, but it makes no sense. So, Israel decided not to fight nature, but outsmart it. That's how around 2018 a project was born that sounds like it defies physics. The National Carrier Flow Reversal. The same system that once pulled water from the Kinneret to the sea now works the other way around, pumping seawater uphill against gravity. The idea is simple yet brilliant. Seawater comes in from the coast, passes through massive desalination plants, and only then gets sent inland to the places that really need it. The most amazing thing is Israel didn't even have to build new plants. The country had long mastered the art of turning salt water into fresh water. The Ashkelon Desalination Plant is in many ways a symbol of Israel's water miracle. When it launched in 2005, the whole world was talking about how Israel managed to defeat thirst. Back then, it was the largest facility of its kind on the planet. Sitting right on the Mediterranean coast, the plant looks like an industrial city. Miles of pipes, huge reservoirs, powerful pumps, nonstop operation. It doesn't just purify water. It makes the entire national water system possible, as we know it today. Every year, Ashkelon produces around 32 billion gallons of fresh water. Hard to picture, so let's put it this way. That's enough to supply a whole metropolis. Or, as engineers say, about a third of Israel's population in the mid-200s. From here, water flows into the national network distributed across cities, towns, and farming regions. Everyone in one way or another gets part of their water from this very plant. Then came Sorek, launched in 2013. An even more impressive part of the new system. It's a true giant capable of producing 40 billion gallons of fresh water each year. The membranes here are the largest in the world, making the process faster and more efficient. Besides these, there are 3 more desalination plants contributing to the Kinneret replenishment, together producing over 80 billion gallons of water per year. All desalination plants connected to the National Carrier Flow Reversal System operate on the principle of reverse osmosis. Simply put, it's standard filtration taken to perfection. The resulting water is then enriched a bit. It's too pure, too low in minerals. For normal drinking and to protect pipes from corrosion, it has to be balanced. But desalinated water doesn't flow endlessly into the Kinneret. It's also needed to meet the country's demand. Everything is carefully calculated. Israel's water authority monitors the lake's level, focusing on the red and black lines. The lower red line marks the point where the Kinneret starts suffocating, the ecosystem suffers, the shores dry up and algae take over. If the level drops below that mark and the rainy season turns out weak, the reverse system is activated. Desalinated water starts being pumped into the Kinneret, and all water extraction from it stops. But desalinated water still has to travel uphill. And that couldn't be done without the old water network. Israel became the first country on Earth to make seawater climb a mountain in order to save its natural lake. Once the Kinneret supplied water to the nation, but now the nation gives water back to the Kinneret 8 life-saving arteries. To make the water flow the other way, the country had to literally rebuild itself. Old pipes, pumping stations, filters, everything that had been pushing water downhill for decades now had to lift it uphill. The old pumps couldn't handle the pressure. The pipes were too narrow, and the stations were designed for the opposite flow. So, engineers from Kinneret began reassembling Israel's water system like a giant construction set. The project cost nearly $1 billion shekels, about $274 million. For that money, the country built something it had never had before, a real water elevator. A new pipeline now runs from the Mediterranean coast roughly 18 m through valleys and hills all the way to the Galilee. The terrain is challenging. Rocks, steep drops, scorching heat, but the pipe can't stop. On the map, it stretches from the coast northward, passing under olive groves and between hills where there had never been roads. It ends at the Salmon Reservoir. It became the final point where desalinated Mediterranean water takes a short pause before entering the Kinneret. Here the pressure is balanced, the flow stabilizes, and control systems check water quality. All this ensures that the supply to the lake goes exactly on schedule, without jolts or surges that could disrupt its balance. The reservoir itself looks like a calm mirror among the hills of Lower Galilee, but inside it's the heart of the entire new system. From here, engineers can manage supply volumes, redirect flows to different sections of the network, and adjust pressure according to the season. Together with a pumping station, it completes a closed loop that for the first time in Israel's history lets water flow in reverse, not from the Kinneret to the coast, but back toward the lake itself, the country's source. One of the most striking parts of the new infrastructure is the giant 5.4 feet wide pipeline laid parallel to the old national water carrier. This artery literally flips history. Now the water runs in the opposite direction. As the project advanced, dozens of miles of new connections were installed, old sections were reinforced, valves replaced, and substations upgraded. Some parts had to be literally cut into living landscapes. A new pumping station was also built near Inurum. It provides the main water lift. Several smaller ones are scattered along the route, forming a cascade that lets the water rise gradually, without overloads. By the end of 2022, after almost 5 years of work, the project was completed. Now, whenever the level of the Kinneret begins to drop, all it takes is a command from the Water Resources Control Center to start the pumps, and purified fresh Mediterranean water begins its journey toward the lake. By 2023, Israel became the first country in the world to use seawater to maintain and save its natural freshwater lake. During the autumn and winter, when water levels usually fall, the Kinneret receives up to 1.3 million gallons per hour of Mediterranean water. The Israelis achieved something no one else has done before. Yet, the rescue of the Kinneret isn't just the result of this new system. Israel is a country that has mastered the art of living with water scarcity. And sometimes their ways of saving water might seem unusual to others. Any water matters in Israel. They're saving Lake Kinneret not only by desalinating seawater, but also by learning how to reuse water, literally bringing it back to life. Every gallon that gets treated and returned to the system is a gallon that doesn't have to be taken from the country's most important lake. Today, Israel recycles about 90% of its wastewater. That's a world record. For comparison, the average in European countries is around 30%, and in the US, it's under 10%. Almost all of that treated water goes to agriculture, fields, orchards, and vineyards. What once was sewage now irrigates wheat, citrus trees, and even flowers growing in the desert. And all this is possible thanks to a massive engineering system that rivals the national water carrier in scale. At the heart of this system is the Shaft Ton treatment plant located between Tel Aviv and Ras Horn Zion. It's been operating since the early 1980s and is now considered one of the most advanced in the world. Its job is to process wastewater from the country's largest urban area, home to more than 2 million people. Every day, about 98 million gallons of wastewater arrive here and go through several stages of purification, mechanical, biological, and sand and soil filtration. After that, the water becomes clean enough to be safely used for irrigation without harming soil or crops. But Shaft Ton isn't just a treatment plant. It's a whole ecosystem where water undergoes natural purification through sandy layers near Rova and Ness Iona. There it's filtered once again underground as if returning to nature to become life-giving water anew, then pumps lift it back up, sending it into irrigation channels that stretch south toward the NGV fields. Thanks to this project, Israeli agriculture receives about 37 billion gallons of purified water every year, meaning it needs far less fresh water from Lake Kinneret. Besides Shaft Tun, the country has more than 150 treatment facilities, from large ones in Haftu and Jerusalem to smaller rural complexes. They're all connected in one system managed by the National Water Authority. Modern plants are equipped with quality control systems and labs that test the water daily by dozens of parameters. In Israel, they like to say, "We don't have wastewater. We have reused water." This technology has freed up huge volumes of fresh water, eased the strain on Lake Kinneret, and stabilized the country's water balance. Even with this, the country would not be as successful in terms of water conservation. There are other equally important ways to conserve this vital resource. The unique philosophy of Israel in Israel, saving water, isn't just a habit. It's a philosophy rooted in the very existence of the country. Here, every drop is like a coin in the family budget. Israel lives in the desert, and that's why it learned to see water as the most precious thing it has. It's not some lofty statements. It's pure math. Little rain, few sources, but increasingly more people. And under these conditions, water isn't something you just extract. It's something you preserve. The true wonder of Israel's water system is how little of it gets lost. Water losses in the pipelines here are incredibly low, around 5%, at most 10% in some areas. For comparison, the global average is 20 to 30%. In Israel, every pipe is monitored. Every leak is tracked in real time. Pressure sensors, electronic valves, instant alerts. All this isn't a luxury. It's part of everyday routine. If water disappears somewhere in the network, they know about it within minutes. And not because they fear losses, but because water here is treated like a living system that must be kept under control like an organism. But the real philosophy of saving water isn't born in the pipes. It's born on the land. Israeli agriculture is proof that you can grow crops in places where it rains only a couple of times a year. Here, water doesn't flow in streams, it drips. It was in Israel in the mid-10th century that drip irrigation was invented. A simple but revolutionary idea where water goes straight to the roots slowly drop by drop with no evaporation or waste. This technology, developed commercially by the company Netafim, changed agriculture worldwide. Today it's used from Spain to India. But in Israel, it became a symbol of common sense. Water the plants, not the fields. Over time, drip irrigation got smart. Farms now use sensors that track soil moisture and air temperature. Some companies have made irrigation ultra-precise. Their systems analyze data from satellites, sensors, even from the plants themselves. When the roots need more moisture, the system sends a signal and opens a valve for exactly as long as needed, not a drop more. Sometimes the farmer doesn't even get involved. Algorithms manage everything automatically. Thanks to such precision, water use drops by dozens of %. And it's all built on a simple idea. Just smart water that knows where to go. Even at home, people install systems for reusing water. For example, the water from the shower or washing machine is used to water the garden. In schools, children are taught to turn off the tap while brushing their teeth. It doesn't look like obsessive frugality. It's part of the culture. People here say, "We don't save water, we help it live longer." And maybe that's the real Israeli miracle. Not desalination or pipelines, but attitude. In a country where huge parts are desert and the rest is almost desert, people have learned not to wait for rain, but to create their own water cycle. Every drop here isn't just a resource, it's part of life. And maybe that's why Israel became the country where water doesn't disappear. Who knows, maybe soon another revolutionary water-saving technology will appear in Israel. After all, that's where drip irrigation once appeared. Just take a look at the country's agriculture. In Israel, any technology in this field is revolutionary. Robots to guard the crops. In Israel, bees are becoming fewer, yet the amount of work they have to do keeps growing. Orchards and plantations are expanding. Crops demand precision and consistency, but natural pollinators can't keep up. The climate adds fuel to the fire. Heat, dry winds, sudden cold snaps. All this throws bees off their usual rhythm. And without their labor, there would be no avocados, no blueberries, no many other crops.